Okay, I'm gonna pull out the stream shoot. I'm gonna just have the handheld on to just the stream.
Okay. Ready for me? Test one, two. Test one, two. Are you hearing me through the stream, Jules? Can you hear me through the stream? Test one, two. Test one, two.
Test 1, 2. Yep.
Okay.
Yes. Hello. Test. 1, 2. 1, 2. Test. 1, 2. It's coming through? Yep.
Okay. So the mic's okay.
Okay. Great. Okay. Mics are working on screen.
I grew up in Kentucky in severe poverty, dyslexic as I can be, but I turned out to be very imaginative. Dr. Phillip Sharp received the Nobel Prize in 1977. I made the discovery of split genes and RNA splicing. The idea to make drugs out of it. There was a time when the biotechnology industry didn't exist. Did I know you had to raise hundreds of millions of dollars to make a pharmaceutical? And most companies fail. Was step forward and see where it goes. In 2024 alone, more than 7.6 billion people were treated with a biotechnology drug, with the promise for more to come. Holy, you know what?
Welcome to The Dish, where we invite entrepreneurs to share their insights into the next generation of biotech companies. I'm Johannes, founder and chairman at Lab Central and CEO of BioLife. After more than a decade of working with entrepreneurs and supporting more than 1,200 startups, I'm here to bring you stories from our ecosystem. Are you ready to dish?
Live from Lab Central Lobby at 700 Main Street in front of a live studio audience, please welcome your host of The Dish, Johannes Freyhoff, and his special guest, Phillip Sharp.
Welcome, everyone. Welcome to The Dish, and a special welcome today to our guest, Dr. Phillip Sharp, MIT Institute professor and Nobel Prize winner for his 1977 discovery of DNA splicing, which, of course, fits the modern biotech industry and era. Philip later went on to co-found important biotech companies like Biogen and Alnylam. And so that's what we're here to talk about today. Thank you so much for joining us. It's a pleasure. And we typically start our interviews by asking our guests to bring an orange object. Today, we bring you an orange gift. And so Phil, as you will see if you watch his documentary, is from Kentucky. So we found an orange object from Kentucky, bourbon, Colonel Taylor bourbon. And we understand that Colonel Taylor was an innovator in his own time. So thank you very much. Let's get started with talking about your most famous discovery, the splicing of RNA. Uh, we have many scientists. Who is a scientist in the crowd? Who has made a similarly important discovery? All right, so please share with us how that feels. How that feels when you see that for the first time, when you understand that. Take us back to that moment.
Well, it's hard to really communicate in science. But in the lab, we had been working on this system of biomarkers for 2 years at different levels. And ultimately, we came to the conclusion that there had to be a unusual pattern. And we did an experiment with they saw these three loops. And the loops told us that the sequences in the RNA that's the message is being spliced together. And the intervening sequence are being removed. And when I saw it in the electron microscope, I was stunned. We had to collect a lot of data to make sure that it was reproducible and the structures that we were seeing were coherent. And then it was, what do you name it? What do you name it? Nobody else. And so we incubated RNA splicing as the name. And then the stuff is you and I and two other people understand this, but we are going to communicate. And we are going to get it. And then we reached out to my colleague Dave Bolton at MIT, who was a member of the National Academy. And I brought him in and we explained what we were doing and asked him to communicate a paper. It was, it was absolutely thrilling. And then the big questions were how to make it meaningful up here. And the world rolled on. But, you go home and you talk to people, but they don't know.
How long is the process of a discovery? You knew you were searching for something.
I was for almost 6 months. I knew I was searching for something.
Yeah.
That was unusual. I didn't know the answer, but I knew it was unusual. And then there was a moment in which it became clear. And that was a year ago. And it was a time to make the first of this study. There were three loops. See, three loops, where they place together. I knew that's the way cellular genes are.
What gene were you looking for?
I was looking at an amylase gene.
Yeah.
But there was 20 years of literature that basically said, learn this literature. And no one was really paying attention. And I knew that the created the simple logic was clear, systematic spacing. So it was fabulous.
Yeah. And now, of course, that allows us to have all the human proteins encoded by a small number of sequences, relatively smaller number of sequences.
That's sort of we were 20,000 genes. There was a small worm that lives in that soil that was 19,000. But we had tracing this. And it's an elaborate, it's a sense of complexity with a limited amount of information. And that occurred at some stage in evolution. It's the multi-cellular organisms and doing all the wonderful things in humans.
It's a unique way of using limited genetic information. Right. And of course, it has many disease implications because there are many diseases that are caused by splicing operation or that can be addressed by fixing them.
Yes, more than we know right now. And, there's indications that we're going to be able to address these.
Yeah.
And that will give us a whole other tool to how to modulate genes and treat disease.
Yeah. So talking about treating disease, I was particularly happy to have you accept our invitation for this interview because you're more than just a basic scientist. You're also the pillar of the biotech industry. In Lab Central now, we do what you did with your peers in the 70s, which is found your first biotech company. Take us back to those years of creating Biogen.
Well, the creation of biotech came out of the academic labs. And you recall in 1975, Cambridge itself was in demo about whether we could do recombinant DNA here in Cambridge. Same year I did the discovery of RNA splicing, we get a call from Ray Schaefer, who was an MIT alum, to go and consult on an investment in a biotech company. And I didn't know where he came from. And I actually, at that stage, nothing about it. And I flew out to San Francisco. And then walked Bob Swanson, the founders, and they sent me a diagram. We have it in my files of the synthesis of the first instrument, synthetic insulin, then growth hormone. And they said, this is fantastic, and there's Ray Schaefer had the option of being the first external investor in the company. And they took the option, bought 13% of it. And then there was a conversation that started between Ray Schaefer and myself, Wally Gilbert, and Landry at PA Circuits, that we should invite a number of European scientists and Wally Gilbert myself to a conference in Geneva. And it's about what we found in Geneva, but then started thinking of encompassing all these groups and in one biotech company. That was just amazing. We held a conference. The European colleagues had a much more reason to get involved than we were. But we ultimately, in the second meeting, and it was soon noticed Geneva, and so it's very nice demos. In the second meeting, we decided to go forward and form the company. And it was like sitting there saying, I should tell you something. I'm trained as a the University of Illinois. And 3 out of every 4 graduate students in that very good department were going into the chemical industry. It was an objective. And here we had synthetic biology. We could make things. And it was similar. And you make this ability to make things and make things useful. And Biogen was founded on 3 pillars. We're going to do biomedical science, synthetic chemistry, making intermediates, and then ultimately became a biotech. It was like being able to find own chemistry. And really, that's going to be cool. Really, really we didn't even know what we were signing up for. Not even close. But it soon became clear that you had to raise a lot of money, and you had to engage with people, and you had to create a very good business plan and leadership. The one thing I've learned, you know, is if you're going to start a company and you have great science, with great management, CEO, take the great CEO. Because if you got the right leader, you can create the science, you can change the science. But it's very difficult to change the CEO. So we made every mistake in it. By being a first doctor, and getting, we were able to look through those. Company was established in 78. The first approved product, which now owned, was in 86. It was alpha interferon for cell. And that's 8 years. So founding the company, the was discovered in 79 by Charles Wesley. For 7 years in the gene. And they got approval. But we were losing money like you couldn't imagine at that stage. We had gone public at 23. We were creating it from about sweat. And we recruited Jim Benson to come in and take over CEO. He was an entrepreneur, a very experienced one. And then we got evidence, medicine in front, looking for multiple sclerosis and arthritis. And it's a wonderful day when you're positive.
Liberating. It is liberating. Look back to those days of the public discussion at in the birth years of biotechnology. People were very scared of this unleashing of the brilliance and Frankenstein is going to rise and do us all or something, right? Like this public discussion that ultimately led, in my understanding, to what Cambridge is today. Well, I guess myself. I mean, okay, so 75 was the moratorium. It came out of the concern that people were going to make requirements means that if distributed to a bacteria would create disease in it.
Mhm.
And putting more genes in the bacteria, putting giving proteins in the bacteria. So became a concern in an academic debate. Meeting in New Hampshire, there was a letter written to the National Academy saying, we think there should be a moratorium for a year to get guidelines in place for doing this research to reassure the public that we are considering their benefit as well as our interest in doing this. So we had a moratorium, NIH guidelines, the Asilomar Conference drafted some recommendations, and I protected those, publicly disclosed them, posted them. We began to think about doing these experiments in Cambridge, and Mayor Blue said, no,
You didn't want it here.
nope, you can't do recombinant DNA in Cambridge until the city of Cambridge tells you can't. And there was hearings in City Hall. And then a really interesting procedure where citizens from Cambridge were volunteered for a committee. They met with scientists, learned about the technology, learned about the hope of the technology, and ultimately came about a year later to the city council and said, we think this should proceed.
Mhm.
So once then the city council issued regulations for recombinant DNA labs. So when Biogen moved into Cambridge, they went to the city manager and said, we'll adhere to these guidelines. Will you approve us building a lab here? And they said, yes. So you were the only city in the country that had any regulations for doing recombinant DNA.
And that became the moment.
It's when I
It's so ironic and lucky that this moment that was built to stop the biotech industry led to it really having a human impact because it was predictable.
was predictable. You can invest tens and more millions of dollars building a facility, renovating a facility, unless you know you can do something in it. So the regulations were really
Yeah. It's really fascinating to think about that history. So take us from that moment to
regulations in the high-tech medical industry are very important. That's why the FDA is very important. If you have a set of rules, you can set aside those rules and you can do it. But if that's changing,
Mhm.
or if that's unpredictable, then the amount of investment you're going to get will go down. Because uncertainty is the most negative thing you can have.
Because there's enough risk in the science.
So it's actually great thing other than
Right.
something else.
That takes us to exactly where I wanted to take you, which is this moment in biotech where we have that uncertainty and a little bit of chaos that we're working through. At the same time, we have tools like we've never had before in science. What do you make of this moment?
I think the moment is somewhat is created by the uncertainty and chaos that we're talking about. And that's a big blanket
Mm.
on the industry.
the innovation side is really is becoming more relevant, more impactful. And we've made stunning advances in immunotherapy treatment of cancer. We're going to have more. We've got scientific advances in how we understand the nervous system, mental disease, chronic mental disease, and others. We'll be able to treat those. And we'll have treatments and things that we haven't even worked as a But the system has got to be in a way that they accept and support and approve. And if you don't have that endpoint, you won't have the investors at the beginning. And so I think that's coming back. I think we're at the nadir of it all, and we're going to see more investment and more innovation. But the last 5 years have been very difficult.
Yeah. Ups and downs in biotech. We saw the hype with COVID and then the punishment afterwards. When we spoke a week ago, we talked about the fantastic basic science that's happening and innovation leading to new drugs, but healthcare delivery and the access for patients is not really where it should be. And in this country, we're paying a large amount of healthcare costs for not the very best healthcare in the world.
I think we have the best healthcare. We, but even there, it's my impression that the degree of innovation we have in the discovery, new treatment, new biology side is not matched by the innovation in healthcare quality. We're spending 18 to 19% of our GDP for healthcare. That is, I mean, that's the upper limit. Probably what our economy can be. So we need more innovation in healthcare delivery. And that comes all the way from how to communicate better to citizens, the different patients, and to deliver healthcare with people contact in different ways. I think most professionals, assistants are going to become more common supporting the information in place. So, and then healthcare economy and education, support benefits in different locations. So I think there's going to be a growing impact of AI in that area. That is an opportunity for innovation and for companies as well as for the discovery side. So I think that's what the next 10 years is pretty much the next 10 years is going to be about.
Yeah, we showed you our new AI biohub at Lab Central, where hopefully some of these new solutions will be birthed.
How many GPUs do you have?
When we met last week, I was trying to enroll you on this mission of defending science against the public discussion that's criticizing science, and you had a different point of view.
I don't think you can defend science. You have to be the people who don't fight what we do. You have to meet them where they're at and teach them what they're doing and why you're doing it and how you're doing it and what the uncertainty is in that process. I went down to the National Academy and was part of a meeting at the National Academy about 6 months ago. And the head of the National Academy got up and said, in essence, we have a truth. We have a truth. I get up every day wondering what the truth is. Because everything's related to everything. It goes down in the pandemic, you reduce infection, but you keep kids out of school. Right? How do you balance it? What's the truth? How do you ask the value that, you know, impact lower education for the whole university against the increased spread you get if you don't lock things down. And there's that type of trade-off is common in everything we do. Like, when you get up and tell people, look them in the eye and say, I'm a scientist, I know the truth. They know. And you have to meet them. And given the trade-offs, given the probabilities, as you see it, this is the best way to see it. That's definitely incredible and I have it because that's and it's really I do think it have the community that can find a way to help them and meet them. It's sort of the group of being an entity,
Yeah.
being part of the scientific community. And we do a well of it. We have a lot of communication with people, not in the other parts, many parts of the country.
Talking about community is another topic that we wanted to take up. At Lab Central, we try to build community for our innovators. And in some of the materials that I watched in preparation to get to know you a little bit better, community is also important for you, scientific community, and how it has to work together to get to a product. It's not the single scientist in most cases. Talk to us what community means for you in science and in business.
The community is amazing. And it's really the most pleasurable thing of doing it. Because you can bring people around you, work with them, business people, regulatory, marketing, and manufacturing, everybody. And they're all necessary to accomplish what needs to be accomplished. And you have to treat all of them with respect, thank them for what they're doing, and work with them for these things happen. And that gives you an way to include the most set of people in their lives and what they're interested in. And it also enriches you because as you learn more about what motivates them and how they, you see places where you can become involved, so help them in different activities. So the ability to create a community is important. Now, one of the things that's happening now, in this particular time and place, is that we have begun to substitute Zoom for community. And that's an assumption. Right? You can build the community that is this people as people in a room working together by Zoom. And we'll see. Maybe some things are easier, some things are better. You can engage people at a distance much more effectively than probably people living. I have a lot of concern that we are losing something in the educational interactions, connectivity by not being together and being eye to eye and learning about people and just trying to motivate each other.
One of the principles that we've built Lab Central on is exactly that community. And we say we want to reduce friction and maximize collisions for people, meaning we want to bring people together in our corridors, in our cafes, at events like this. Thank you all for showing up. And not just on the live stream. So important.
Oh, it is. And so when you must speak a little bit about it, and I
Yeah.
go to the solution. I grew out of the scientific institute in Andy for 1988 in Cleveland. Andy was my grad student. With this, we were friends. And
And he wasn't even a biologist to begin with.
he was a mathematician. And when he was 19, he was a leader on his PhD. He, he is brilliant. He was brilliant. There was a lot of time in the room. And so they made this discovery and make a living taking phenomena and turning it into chemistry. So I, David Barthel and Bill Zamar, we developed the bicycle system.
We're talking about the late 1990s now.
In 1999, we signed, and in 2001, we knew that these organs were being developed.
So for who knows RNAi, or who does not know RNAi? On his 12 hands. RNAi means silencing, of course, the principle that underlies alnylam.
The principle is simple. You have a gene, make double-stranded RNA from that gene, and if the organism is sensitive to RNAi, that double-stranded RNA will silence the gene. It was discovered in nematodes. And I just, and so, yeah, stunning. As soon as I read that paper, I said, just look on man's house, we have a whole new organ. It was suppressed. It was a stunning way of silencing a gene. So we worked out the biochemistry. And so if you can translate this to human disease, you have the genome was just different. We had the genome sequence. We knew a gene against disease.
Now we can silence it.
And then we have the sequence. Well, we can design an RNA. And then the big issue was we introduced the RNA into cells. So that was the delivery method. And when we decided to do this, we came up to millennium and asked if I could we could pitch the millennium with the team. We made it there. I knew they could believe it. Because they had everything was they had to deal with. But it was the most exciting company in Cambridge. And by keeping everybody that we were thinking about starting a business. And then the different. So we launched the company with Polaris. And was
Westphal.
was the CEO. We recruited the management team from Berlin. But 2002 was a difficult time to start a company. I mean, we were in one of these biotech
Plus,
laws. Not as bad as it is now. But it was really, really difficult. We had formulation books and Biogen was a wonderful, it is a wonderful. And we were able to launch the company. And so the delivery problem was lipid nanoparticles,
right.
which became Advance's method for delivering mRNA.
Right.
And it's one of the method of delivering RNA vaccines to treat cancer. And it's going to become the method of RNA delivery to CAR T cells to enhance immunotherapy. So it really science building on science.
In the whole community of science.
Yeah. With Langer and others and starters. And it's
Now Alnylam has multiple approved therapies on the basis of science. Yeah. I also enjoyed you telling the story of how you sent Tom Tuschl out to find that sequence or that structure that actually endorses RNA interference.
No, he was It's just not so. You can do a postdoc with myself and David Bartok. We haven't worked on spacing and so we did the folk. The project I gave them to do, and he wanted to do, we said never about it. Because the way really thing to the other end, we know it was not an answer. Um, but the paper, it was interesting, but he had 2 months left before he had to go to Germany. And he said, well, do you want me to came in to talk to me? What we're going to do is you want to continue or do you want, and he's, and I said, you should take these 2 months and to see if you can get a Michael tools anymore and then we can have a acoustic Friday afternoon. He works in the office and says, I think we have a signal in Michael to react to specificity. So he'll go home and he went for a weekend. Everything's and everything and it seems you know, so this beautiful signal that said this is the biochemical reaction where we could really the and then we had set up the delivery program, lipid nanoparticles, APOs, and disease target in the liver. And then we solved the delivery problem another way with subQ IV. And now it's taking about announcements that modality. I mean, it will be terrible to have for themselves. Yeah. And whether it work in the central nervous system is a big thing too. There's some evidence that this also will. And if you can get gene-specific inhibition in the central nervous system, I think you can do some wonderful things. So well, that's something. Not that's 10 years old, but it's a little bit the young journal. Really, you can do this. If you have like a nanoparticles, you can do RNA vaccines. With RNA vaccines, you can do from T-cell delivery. It grows in itself. It's one of the more exciting ways you can build your day-to-day existence.
I think that's so interesting because you span multiple decades now of science and also the business of science. And you have this perspective of founding Biogen in the 70s and then Nobel in the 2000s, and now we are 20, 25 years later. And to see what's different and what still remains the same between those periods.
Well, it's different. The science is much more sophisticated. And it's going to be mixed with AI, which is really dependent on large amounts of data, which we will get, which will allow us to formulate our hypothesis much more precisely and identify the causes of genes much more precisely. And then be a higher probability that when we make our investments, we will be able to be successful. And even in the process of designing chemicals, drugs, we will be using AI in the process of understanding systems, physiological systems. We will be using AI and big data in the process of guiding patients to the right place, the right physician, the right treatment. We'll be using AI. In the process of calling them in the morning and asking if they took their meds.
Right.
We'll be using AI. So it's
So you're not scared of the AI wave that's marching on us. See it.
most of the data. There's things that are going to be displacements.
Yeah.
One we're talking about is, the impact of social media and how that's going to intimacy. So That's very important. And then the other thing we're going to need to think about is economic displacement. Because there's going to be a lot of jobs that are not as difficult. More people can do more. Then what's society going to look like? Because the ability to work, the ability to be meaningful in what you're doing is very important in people. And it'll be interesting to see what the next 20 years holds. Because a lot of us are going to be doing things that are different that we are not.
Thank you so much. We will want to look in the future. There's one question that an audience member asked me to put to you that I do want to put in before we open it all up for all of you, which was he wondered if you won the Nobel Prize, and that's sort of the highlight of a scientific career. And many scientists aspire to even attain the Nobel Prize. But he was asking, is there anything non-desirable about winning the Nobel Prize?
Well, there's lots of things desirable.
Yes.
And one of the most pleasant parts of winning the Nobel Prize is to go to Sweden for a week to celebrate it. I have never experienced anything as uplifting, wonderful as that week. They give you an invitation, you take you to the best friends, you go to you have the best musicians, opera singers, dinners. It goes on for a week. You have at the end of a dinner in the city hall for 1,100 people. With the king and the queen. And then you go to the house to get some everybody applause. Then you go to the nightcap and they get you drink. In my middle daughter at that stage was we went to the cookout for me. Nightcap. We went home at 2. They went home at 4.
Oh,
Went back to the hotel. Changed their clothes. Walked out the door. Got in a cab. Went to the airport. Flew to Philadelphia. Went in the next morning and took the final in biology.
wow.
Got an A in the course. So I don't believe that was on notoriety of like this.
No, that was not.
It's really, I mean, and then you want a list. List of the country. So anyone organizing a meeting, and they have 20 people on the list. Who are you going to invite out of that 20? Well, I Philip person just got a Nobel Prize. Why don't we invite them? So, really hard on that. And then, I mean, there's a downside to public exposure. And in my case, it was a Unabomber. And the FBI called us at 2 in the morning and said, we have a reason to think that you might be targeted by the Unabomber. Now, the Unabomber had bombs that explode out of packages and damaged 23 people and killed 10 of them. And they said, don't open your mail. And then I said, I don't open my mail. My assistant opens my mail at MIT in the morning. Somebody has to be there before she could possibly open the mail. So for the next month, the FBI scanned my mail at MIT and in Newton. They intercepted a letter, but not a bomb. And but I continued to do my work and travel. I got security everywhere I went. But there's always a other side to things, and I will make a recommendation. If somebody calls you at 6 in the morning and says, will you accept a Nobel Prize, which they ask you, I would say yes.
That's a great moment, I think, for us to turn it over to the audience. We have a few minutes to take direct audience questions for Dr. Sharp. Please, if you have some, we have a microphone over there, and so you can ask your direct question of him. Daniele, right here.
Thanks so much. Looking back over your life or your career, what's the thing you're proudest the most?
Oh, what's the thing I am most proud of? I'm proud of it. I'll phrase it this way. If I on that list is the discovery of RNA splicing and the recognition of a Nobel Prize and being a leader in science. On that list is starting Biogen and helping to cure multiple sclerosis, PER, a host of diseases that control people's lives. Right? If I had to give up one of those, I'd give up the prize if I could do the other. But, they're both on that list and they're wonderful. But if I have to give up one, in some theoretical life in the future, I'd rather help others directly by creating new medicines, new treatments, just doing science and helping other people.
Hi, thank you very much. It was very inspiring to listen to you. My question pertains to one of your comments about AI. I think there's a lot of companies that emerged over the last decade that use machine learning and AI in very creative ways, like Tempest, like artificial cell staining. Is there an area in biotech or in healthcare where you think that the impact of AI is exaggerated or doesn't have the potential that people think it has?
It's all exaggerated. It's almost identical in what happened in recombinant DNA. So we had a discovery. It was on the front page of the New York Times. It was going to create a whole new industry. And then people started thinking about it and said, oh, you can create, disease here. We don't know what's going to happen. We don't know what economic impact it's going to be. And then there was a great deal of debate. That's why we had this debate in Cambridge. That's why there was a national debate. And then the next step in it, you start. Then everybody says, well, where's all these benefits? You promised me on the front page of every newspaper that there would be benefits from this. Where are the benefits? And you're losing money. Not a little money. You're losing hundreds of millions of dollars of money. Where's the benefits? And then they start emerging. At the same time, there's debate about the risk and everything else. So it'll play out in that form. But I think it will have ultimately 10, 20 years from now, a bigger impact than most things we're debating right now. That's the way I see it. It's not going to be the single technical advance. Computing with quantum computing, which we will get next 10 years, we'll be able to carry 100 times more computing capacity on our cell phone than we can now. with a lot more memory, coming instantly, algorithms that will solve problems when you phrase them correct and give you suggestions for what you can do, and media you can't even imagine. So what? That's a big change, and it's going to ultimately change everyone. Medicine, there's a targeted population. This is everybody walking on Earth. So it's really an exciting moment. I can't anticipate how it's going to work out. Oh, yeah, I'd sort of like to be, but probably not going to happen. It's sort of like to be here. I think it's terribly exciting. We've not, in the history of mankind, seen anything like it.
Cameron.
So, with those exciting words about the future, what one or two pieces of advice would you have for young scientists who are going to make all these changes happen over the next 20 to 30 years?
My only advice is be optimistic, take risk, because you almost have to take risks. You have to ask, you have to pursue, or you never get the word yes. All right. And the support you need. And don't get discouraged. Um, it's really it, it's easy to get discouraged and turn away. But if you have people around you who are, supportive and help you and contribute with you, make a community, um, and I think the opportunities are wonderful. But it's a time we're in the middle of a mood of uncertainty and pessimism in some way, and I think it'll turn, and we'll be much more optimistic. But it's a complicated. Don't don't get discouraged. Just there is an opportunity there. You just have to find it and get to it.
Oh, right here.
Thank you so much for being here. And thank you for your contributions to RNA and mRNA. And in recognizing that, I'm just curious, it's kind of maybe a funny question, maybe not. But with your contributions to RNA and mRNA, did you know Bob Langer at the time? Did he invite you to join in on Moderna? And if not, do you give him a hard time about it now?
Oh yes, I've known Bob for since I came to MIT 50 years ago. We've collaborated. We have a joint postdoc now. When we started at Nylum, we invited Bob to be on the scientific advisory board, and he actually made major contributions with Dan Anderson at MIT to the whole lipid nanoparticle. I mean, we took the concept of lipid nanoparticles that Peter Collis really contributed a lot to, and increased the efficiency 1,000-fold, and introduced the type of chemistry where the lipids actually are metabolized after they're introduced into the body to make that technology something that could be used. And then Bob and uh, uh, others started an island with messenger RNA. And we talk, but I had an island at that stage, and he launched Moderna, and that's fine. I, I wouldn't.
Thank you very much. Got him in my arm. Isn't it?
Yeah, you have to have a focus.
Yeah.
You have to have a team that's got enough time to really put your effort to it, and the folks who put Moderna together saved our you know what.
Thanks for sharing this time with us. It's been great to listen. I think all of us are going to go home for the holidays and spend some great time with family soon. What are you excited about coming back to immediately? Like, what are you working on right now that has you excited?
Oh, I'm excited. I'm working. My last investigator in my lab is going to leave at the end of the year. And he's got a great job down at Columbia, and he's going to be supported by Chan Zuckerberg. He's in a sweet spot. Jay Mahat. But I am on the scientific advisory board of Dew Point, which is trying to take the new science of condensates and turn it into a process of developing drugs to treat untreatable disease. And Skyhawk, which is developing oral drugs to shift splicing and treat disease. And I'm optimistic that both of them have a real chance to make contributions. And then I'm I'm on several boards, mostly nonprofit now. And there are a number of committees at MIT. MIT is a very dynamic place. If you look at us decade by decade, we're different as a university in what we do. And so I enjoy being there and helping and working with others who try to make change. It's very important. But I don't have trouble getting up in the morning. Life is really quite exciting and lots to do.
Thank you so much. Really inspiring stories. Um, I listened to a lot of the names that you talked about, some very famous scientists, people that we know here in the Boston area. But one surprising thing is I'm not sure I heard a woman's name in all of that list. I'm just wondering, how is that possible? And did CRISPR change that? And if CRISPR didn't change that, what do we need to do as female scientists to be part of these stories?
Oh, we're talking about events. I don't want to make excuses, right? There are a large number of women scientists who are contributing enormously to what we're doing. If you watch the documentary Cracking the Code, which is the one Bill Haney has, Melissa Moore is featured there. She came from my lab. She went to Brandeis, then at University of Massachusetts, elected to the National Academy, chief scientific officer at Moderna, and is mostly consulting now. Rachel Moore Myers, trained in my lab. Went to Millennium. We recruited her to Alnylam. She became senior vice president of research and ran the research at Alnylam. Blair Moore, early professor, she's a professor at Tufts and had a wonderful career at Tufts. So I agree with you. There are not a lot of women's names in those early days. But I think, well, that is changing. There's no question about thinking about it. It's changing into the betterment. And I think I don't want to be naive. It's still more difficult. It's a more complicated world. But it's getting less difficult for women to have great careers. And I've always enjoyed working with my female colleagues. It's just a better environment when people are contributing from multiple backgrounds and multiple differences.
Thank you. I think this is a very important topic for us to consider and end on, Phil. From all of us here at the large Lab Central community, our deepest thanks for spending time with us here today and for all you do for science and for humanity, really. Very inspiring. I think we all leave with lots of thoughts and hope for the future. So that's really great.
Thank you. If you were interested, watch the documentary, Cracking the Code. It's available on PBS and Independent Lens. And I was told yesterday that 1 million households have now watched it.
Let's make that 2 by year's end.
Well,
Let's make that 2 by year's end.
I would be delighted.
Yeah. And so thank you all for coming to join us for this live taping of The Dish in the room and online. And thank you especially to the Lab Central team who made this huge production possible. I look forward to continuing the conversation with all of you about science in and around Kendall Square. And now we send you home to your families to continue the discussion about science over the holidays. Thank you very much.
Thank you.
Thank you so much, Phil.